Okay, hey guys, I am gonna go over a couple of tips for test chapter 5. First of all, I hope you guys are all doing good. I feel like I haven't seen you in so long, and I hope you've been great to Mrs. Schultz and that you have enjoyed your 2 classes with her. I will be back next week. Hopefully, we can catch up then, and you guys are doing great. Here's a little review for test chapter 5. So first, one of the first things you're going to need to do is list multiples of a number. So it might say like list the first 5 non-zero multiples of a number. Hopefully you remember what a multiple is. It just means it's like skip counting by that number. So if you have 8 times 1, oh, look at that. I wrote 7. Why would I write 7? I think because I was looking at a different problem. I was doing this. Okay, so your first multiple is 8. And then we skip count to 16. 8 times 3 is 24, and 8 times 4 is 32. So your first 4 multiples are going to be 8, 16, 24, and 32, multiples of 8. Skip counting by 8 is another way to think of that. Factors in order. Factor is a whole number you multiply together to get a product. So what are some factors of 15? Numbers that you can multiply together and get 15. They want them in order as you're thinking of them. You can think of them and write them all down and then put them in order. So we know 1 times 15 together will get you 15. And 3 times 5 multiplied together will get you 15. I wrote them in order. 1, 3, 5, and 15. Those are all factors of 15. Okay, next up is prime factors. Oh, prime and composite numbers. They're going to give you a number and ask if it is a prime number or a composite number or neither. So, who can tell me what a prime number is? Well, of course you can't answer it because you're just watching this. So prime numbers have 2 factors, 1 and the number that you're talking about. So prime numbers would be like 2. Only 1 times 2 will get you to 2. There's no other numbers you can multiply together to get to 2, so it's prime. Same with 3 and same with 5. Composite numbers are numbers that are greater than 1 that have more than 2 factors. So how can you multiply? What numbers can you multiply to get to 4? Well, you could do 1 times 4. That would get you to 4. And you can also do 2 times 2. So more than 2 factors. 1, 2, and 4 are all factors of 4. Neither, if it's a 1 or a 0, that is neither composite or prime. If you can't remember that, better write that down in your notes. 0 and 1 are neither. The next thing you're going to have to do is state whether a number is divisible by 2, 5, 10, 3, 6, or 9. And here is where I said you could use page 148 and 149 in your book because I told you didn't have to memorize the divisibility rules. So if you want to get your books and open them to that page before you start the test, you may do that, but you're only using that page just for the divisibility rules. Okay, simplify. The next thing you're going to do is write a product of repeat factors and then simplify if possible. Don't forget to simplify if possible. Here's an example of each. So if the question gave you x to the 5th power as a product of repeat factors, it's going to look like x multiplied by x 5 times, x times x times x times x times x. Those are all times. So there should be 5 x's. That would be your answer. Now, can you simplify that? Nope, because we do not know what x is, what the value of x is there. Here's one that you could simplify. 3 to the 4th power, or the 4th power of 3. That means 3 times 3 times 3 times 3. And you can simplify that by solving this. Simplify means to solve, to answer, however you want to think about that. So 3 times 3 equals 9. Times 3 equals 27, times 3 equals 81. So your answer is 81. If you give me 3 times 3 times 3 times 3, it will be incomplete. And I've been giving you guys some grace on a couple of people who have not simplified, but this is your warning. you need to simplify by answering the problem. So I need to see an 81 on here. I need to say 3 times 3 times 3 times 3 equals 81 if that was your problem. Okay, now the reverse is true. If they're going to ask you to give something in exponential form, so the question would look like this. 5 times 5 times 5 times 5. 4 times we're multiplying the number by itself. So that is 5 to the 4th power, or the 4th power of 5. So that would be your answer. Let's say it's x times x times x. That means x. Who remembers the short word for the 3rd power of x? X cubed. So x times x times x equals x cubed. And that is your answer there. All right, moving on. You're going to be asked to multiply some things together. So it might say multiply a to the 2nd power times a to the 2nd power. Remember, when you're multiplying exponents, you add the exponents. So a2 times a2 becomes what? A to the 4th power. Now you can do multiple numbers. It might be x to the 3rd times x to the 5th times x to the 2nd. What do we have to do? We need to write x, and then we're going to add all those together. So 3 plus 5 is 8, plus 2 is 10. So it'd be x to the 10th power. Okay, now when we go to adding though, when we're adding numbers right here, if it says simplify, you have to answer it if you can. So 4 to the 2nd power plus 4 to the 3rd power. Now here we can't just add the exponents together. We need to do the multiplication and the multiplication, and then we need to add those two products together. So it's going to look like this. 4 times 4 plus 4 times 4 times 4. See, 4 to the 3rd and 4 to the 2nd. So 4 times 4 is 16. Plus 4 times 4 times 4 is 64. So your answer would be 80. And that's what I need to see on your test. If you give this to me, you're going to get marked down because I know you know how to multiply those numbers together. So do it if you can. All right. Prime factorization with exponents. They're going to tell you to write the prime factorization of a number like 16. And if the answer can be done in exponential form, you can do that. So what are the prime factors of 16? Remember I said factor trees are my favorite. So you're going to factor those out. Now you can use, instead of doing a factor tree, you can do it as prime, what do they call that? Prime division, where you divide it by prime numbers. That's an option too if you prefer that. So you can do that, or you can do the number tree, but here, factor tree. So 16, I did it 2 times 8. You could have done it 4 times 4. It's going to give you the same number, remember that. So 2 is a prime factor, so we don't need to do anything more of that. 8 can be divided into 2 times 4, so then we have 2, 2, and 4. And then 4 is still not a prime factor, so we need to make that as 2 times 2. So your answer, 16, is 2 times 2 times 2 times 2. And they want you to write that in exponential form. So 2 times 2 times 2 times 2 becomes 2 to the 4th power. So that would be your answer if the question was the prime factors of 16. Okay, let's try it with 50. 50, I divided it as 2 and 25. Now 2 is a prime number, so we can just bring that down to the bottom. And 5 is 5 times 5. 5 is a prime number, so then we have 3 prime factors, and one of those is repeated, so we can do that as an exponential form, which it looks like this. 5 times 5 is the same as 5 to the 2nd power. So 2 times 5 to the 2nd power are the prime factorizations of 50. So your answer, show me your work. So either do it as a product of repeat division, where you do like long division with prime factors, or do the factor tree, and then show me your work, or show me your answer. Should look like this in exponential form. If you give me this 2 times 2 times, or 2 times 5 times 5, I'm going to have to mark it as incomplete. It needs to be, if it asks you to do it in exponential form, you need to do it like this. Okay, then moving on to the lesson that Mrs. Schultz taught you on greatest common factors and least common multiples. So if you need to find the greatest common factor of two numbers, let's say these are your two numbers, you're going to write out all of the prime factorizations and find what is common to each. So we have 2 2s and a 3 are common to each. 2 2s and a 3. Multiply those all together. 2 times 2 is 4, times 3 is 12, and this is your greatest common factor. And then your least common multiple, so here they're also going to give you 2 numbers. They could give you more than that. I think I did this on a second piece of paper, so let me get that. So if they told you to find the least common multiple of 6 and 15, you're going to remember that the least common multiple is the multiple of 2 or more numbers. That's the smallest number that is a multiple of each. So you can either write down all the multiples of 6, 12, remember that's like skip counting by 6, and then all the multiples of 15 until you find one that's common to both. If you write them in order, then that's going to be the lowest common or the least common. So 30 would be the least common multiple between 6 and 5. Now the other way to do that is over here. If you were given the numbers 6 and 15, then you could also do a factor tree and find all of the factors, and then you're going to write down the different prime factors. So the different prime factors are 2, 3, and 5. Okay, 3 is written down, 2 times, but they have to be different. So there's only 3 that are different, 2, 3, and 5. 3 is common to both, but we only write it down once. And then you multiply those together, and the least common multiple is the answer of when you multiply these together. So it's 30. The other way to do that was what I did over here, where I just wrote down all the multiples and then it's still the same answer, 30. You might be given 3 different numbers and you have to find the least common multiple. So write down all the prime factors. I didn't do a factor tree for these, but you probably would need to. So prime factors of 4 is 2 times 2. Prime factors of 18 is 2 times 3 times 3, or 2 times 3 to the second. 45 is 5 times 3 times 3, 5 times 9, or 5 times 3 to the second power. And then from there, you have to find the different factors, and you're going to use the highest exponent from each prime factor. So here's the example. We have 2 here, and here we have 2 to the second power. So use this, and there's no exponent. We know the exponent is 1 because we're just multiplying it one time. So here, this is the greatest, so the highest exponent form. These are the same, so we're going to use it once. So we have this one we're going to use, this one we're going to use, and this one we're going to use. So the different factors are 2 to the second, 3 to the second, and 5. 2 to the second is 2 times 2, or 4. 3 to the second is 3 times 3, or 9. And 5, just lonely old 5 there. So then we have to multiply these all together, which I didn't do. But I'll do those quick in my head so you can see how good my fast math is. I would do 5 times 4 first to get 20. And then 20 times 9 is, 2 times 9 is 18. So it would be 180. Now, of course, you could have listed out all the factors, or all the multiples of 4, all the multiples of 18, all the multiples of 45 until you found one that was common to each. But that would take you a long time. So this way, listing out the prime factors and using the highest exponent for each prime factor is going to be faster. And your answer is 180. Okay. If something of that doesn't make sense, go back to that lesson in your book and look over the instructions there. Also, your chapter review should be helpful. And finally, give me a call if you have any questions on any of that. Review your notes from class too. Remember that I'm going to be in Hawaii until the 8th of November. So if you call me, the time change is 6 hours. I'm 6 hours behind. So if you call me at 8 o'clock in the morning, 8 minus 6 is 2. It's going to be 2 a.m. So probably not going to answer, but I'd love to talk to you if you have any questions. So text me or email me or call me if you need me. Okay, bye.